Okay, so we've found the equation of the line going through negative 3, 5, and 2, 1, and now we're asked to find the x and y intercepts. Okay, well, looks like it's about 3 and 3, but let's look. I'm going to use the standard form in order to find the x and y intercepts. I know that the x-intercept occurs whenever y is 0, and the y-intercept occurs whenever x is 0. So if I put 0 in for x, I have 3y equals 7. Oh, I was a little off there. It looks like y is actually 7/3. Okay, so I'm going through the x-axis at, what's that, 2 1/3, right? 7/3. So you can look, hopefully you graphed it and you can see, but let's see here. Y is 7/3, 2 1/3. Okay, well, I'm obviously, I didn't draw it straight. So thank heavens I have my math to correct my drawing. Now I'm going to put 0 in for y, right? So I would have 2x equals 7. So it looks like x is actually 7/2, which is 3.5. Okay. Oh, that's better. I was looking at the wrong one. 3.5 is the x-intercept. The y-intercept is 2 1/3. Oh, I wasn't as far off as I thought. Sorry. I went to the wrong intercept. 3.5, 0 is the x-intercept. 2 1/3, 0, 2 1/3 is the y-intercept. Blah. There we go. Okay, so that's where standard form comes in nicely to find the x and y intercepts. Of course, slope-intercept form is the best place to find the y-intercept. Silly me. I could have seen the y-intercept right here, 7/3. But I just want to show you what all you can do with all these forms, okay? Next, we're supposed to write the equation of the line that goes through negative 3, 5, and 6, 5. So negative 3, 1, 2, 3, 4, 5, and 6, 1, 2, 3, 4, 5, is this horizontal line. Sometimes people they find these lines to be the most difficult. They're supposed to be not the most difficult. They're supposed to be a little bit easier in that, the equation would just be y equals 5. Okay, the slope is actually 0. If you find the slope, you would take 5 minus 5 over 6 minus negative 3. That gives you 0 over 9. 0. So the slope is 0. So I take y minus the y coordinate equals 0 times x minus the x coordinate. So that's y minus 5 equals 0. Y equals 5. Okay, or you can just notice that what this line is the y coordinate is always 5. X can be anything. We're at 1, 5, 2, 5, 3, 5, 4, 5. Okay, y is just always 5. Okay, now we also have the other side of it. What if it went through negative 3, 5, the same point, negative 3, 5, but then negative 3, negative 1? Well, that line is vertical. And when I try to find the slope of that, 5 minus negative 1 over negative 3 minus negative 3, undefined slope. Okay, I can't use slope-intercept form. I can't use any of the forms. I don't have a slope. Okay, the slope is undefined, not 0. 0. The horizontal line has a slope. It's the slope of 0. This one is an undefined slope, and the equation of that is just that the x coordinate is always negative 3. The only one that's different in that it doesn't fall into that nice form y equals mx plus b or anything. Okay, it's x equals the x coordinate of negative 3. All right. Next, we are going to sketch the graph. of y equals 2/3 x plus 1 and 2x minus 3y equals 9, and that all in the same graph. Okay. All right, so let's try it. This one's not bad. Hopefully you guys are familiar with graphing when it's in slope-intercept form. That's telling me to go through the y-intercept of 1. It's telling me my slope is 2/3, so I go up 2/3, up 2/3. Or I could use two negative moves. Negative 2 over negative 3 is still 2/3. Down 2 to the left 3, down 2 to the left 3. There's y equals 2/3 x plus 1. Now, y equals 2/3, or this, I'm just going to do the intercept method because it's in standard form. I'm going to put 0 in for x. That gives me negative 3y equals 9. Looks like y would be negative 3 when x is 0. When y is 0, I have 2x equals 9. Divide by 2. X is half of 9. 4.5. So I'm going to go to 0, negative 3, and 4.5, 0. Okay, let's see. I have to move myself so I can graph that. Okay, what can I do? 0, negative 3. Oh, these are parallel lines. Okay, if I wanted to find the slope, I'm going to subtract the y's, subtract the x's. I get negative 3 over 9 halves, over negative 9 halves. That's the same as negative 3 times negative 2/9. That's 6/9, or 2/3. So the slope of this is 2/3, and the slope of my other one was 2/3. They're parallel. This other one, 3x plus 2y equals 10. I'm going to do, I always do intercept method when it's in standard form. 0 in for x, 2y equals 10, so y is 5. 0 in for y. 3x equals 10, so that's 10/3. So I'm going to go 0, 5, 3 1/3, 0. Okay. If I do want to know the slope, I'll subtract the y's. 5 minus 0, 0 minus 3 1/3. So I get 5 over negative 10/3, which is 5 times negative 3/10. So this slope is negative 3 halves. These slopes were each 2/3. Okay, I just wanted to show you parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Okay, we flip them and we make them the opposite. Okay, I think we're done. Let me see. Yepers, we're done. Okay, just real quickly, I guess I could have, if you didn't want to do it my way with the intercepts and you want to change everything always to slope intercept, that's fine. Do whatever way you want. You could have taken the 2x minus 3y equals 9, subtracted 2x to each side, negative 3y equals negative 2x plus 9, divide by negative 3. So I have positive 2/3 x minus 3. I took negative 3 and divided by each. I would have seen the y-intercept was negative 3 and the slope was 2/3. I could have graphed that purple line that way instead of the intercept way. Okay, I really doesn't matter to me. It does not matter. There's so many forms. There's so many different ways, right? Math is like pasta. multiple ways to solve problems. So this other one, I could have subtracted the 3x and then divided by 2. And I would have gotten 5 as my y-intercept and gone down 3 over 2. Either way, use intercepts, change it into the other form. Lots of ways. Okay? All right? Wasn't that nice? A little bit of familiar territory? Good. All right. I'll see you in class. Bye.